Hello my friend, welcome back to my 4-Star School YouTube channel. In today's lesson, we are going to learn the dependency management inside the GetX. We have learned the route management, the state management, and GetX controller in our previous lesson. So if you are new here, feel free to reach out to my channel page and you will find a Flutter UI from scratch tutorial and GetX tutorial, also Flutter tutorial and Dart tutorial. So don't forget to subscribe to my channel, sum out my content, and open the notification so you won't miss out the latest Flutter tutorial. And in today's lesson, we're going to focus on the dependency management. As you see from this mind map, I have listed out all the topics we're going to cover in this video. Okay, without further ado, let's get started. And first, we're going to talk the dependency management for create the instance inside the GetX package. And we were talking about the Get.put, Get.lazyPut, Get.put asynchronous, and also Get.create and Get.delete. So let's open our Visual Studio Code and as well as the Android emulator. Here I have wrote some code example and I will walk you through and give you an explanation what it is and how you can use it. So first, as you see from this folder, dependency management folder, I separate our view, controller, and binding, and also some normal class here. And for the class starter, I declare some of the class because I want to show you how can you use this Get.replace and Get.lazyPut. So I create an abstract class called base, and then I create this parent class extend the base, and also the child class extend this parent class. So for the controller, we just define a count variable, also make it observable, and we can increase its value. And also we have its lifecycle method for on init. It will call immediately after the widget is allocated its memory. However, for the onReady, it will call after the widget is rendered on the screen. So if you going to make some API call, and I recommend you put it inside this onInit. If you want to show some dialog or something after the widget is rendered on the screen, you could put it in this onReady. And we also have this onClose method, which will call just before the controller is deleted from the memory. So you could do some cleaning stuff inside this onClose. And for the binding class, we will talk this later when we actually get into this topic. And also for the view, we have this dependence example class, which is stateless the widget. And also we have put our controller, and it's basically just wrap with getMaterial app, and you will return a scaffold, and we have our app bar, and as you see here, have this title GetX Dependency Management. After that, we have this center widget. Also inside we have this column widget. Make this counter in the center of our screen. So we're using this controller.count.value to access the variable inside this controller, as you see here. And also we have this floating action button. When I click this button, the value will increase, as you see here. So that's just our very basic project setup, and we're going to talk about those instantiating method one by one. So for the first instantiation method we're going to talk about is this Get.put, which you will use very often in your project. So let's back to our Visual Studio Code and our emulator. As you see in line 13, I create this final variable I call this Get.put, inject our controller into the memory. As you see here, this is the console when I click this restart button. So first you will initiate this controller as you see here, and then after that you will initiate our getMaterial app controller, and you will see we have controller on init and also controller on ready being called. So for this one, this count variable, we can use this controller.count value to access this count variable. Because we using this Get.put, and we can actually find this controller using this kind of method get.find, and we specify what controller we're going to find, and we could increment this count variable as you see. Another approach is we just create using some default approach as I mentioned here. Okay, for example, we create this controller by ourselves and we save the code, and we need to restart this application. You see we have our controller and we trying to find this controller. However, we didn't call this get.put, so this actually won't work. As you see, the get didn't find the controller because we didn't using this dependency injection instantiation method provided by GetX SDK. So if you want the Get state management to manage your instance, you must using this Get.put, and you inject this class, so it will automatically management those instances for you. So if you call this Get.find, you will return the controller you put into the memory. So I'm going to comment out this one, and we comment out this and save again. We're going to restart our application. By using this approach, we can find our controller and increase this value here, as you see. Okay, this is a first approach. Another thing I want to mention is this Get.put only create a singleton like instant. So for example, I have this controller and I put controller here, and after that I create the second controller. You see we put the same controller, and we're going to save the code, and here I prepare another widget. Okay, I'm going to uncomment it out, so it's the second controller, right? So we're going to restart our application. If I press this button, both of those count variable increase. That means we're using the same controller here, right? As you see from the console, we only instant one controller. So I guess I press this button, both of those numbers will be increased because we share the same controller. As you see, we using this one. So let's try. When I click this number, this button, you see both those numbers increased. That means this Get.put will return the singleton instance for us. If you want to make it multiple instance, you can use another attribute inside this Get.put. You could actually give it a label. Okay, so it means something like here. You give it a label. And the label have this unique ID, right? So by doing this, we're going to restart our application. When you press this button, only the first number will increase, because for the second one, this controller too. So this one won't increase because in here you find the controller. So it means you find the first one and it will only increase the first one. So let's try. Right, you see we only increase the first controller because we have multiple instance. However, if you want to increase the second one, and we're going to use the tag we specified before, it should be the unique ID. The unique ID would be the second controller. We have the send tag, which is unique ID. So I'm going to restart this application, and you will see from the console, first we have this controller initiate, right, which is line 13. After that, we have this controller with unique ID being initiated. So which means our line 22, we create another instance. So when I press this button, the second one will increase, as you see. Let's try. So we increase the second counter because we're using the unique ID as the tag to increase that controller. Just keep in mind, if you're using this Get.put, so every time you're using Get.find, it will return the same instance, unless you give a unique tag for this controller. Okay, that's for our Get.put. Another thing is this terminal attribute. So for example, we have this attribute inside this Get.put. That means you want to keep this controller instance throughout the entire app. And as we all know, if you destroy this view, the controller will remove from the memory as well. So if you want to keep it alive throughout the entire application, you could manually set these terminal to true. Okay, so next we're going to talk about the LazyPut. So let's back to our Visual Studio Code, and we're going to comment out our first controller and also the second one. Okay, I'm going to comment out. In here, we're going to uncomment stop here. Don't worry, I'm going to talk these in later for this binding builder. So first we're going to talk this Get.lazyPut. So in order using this Get.lazyPut, you must put this inside your binding class. So for example, you have your own binding class which implements the binding, right? So you can using LazyPut here. Another way is for the shortcut, you can using this binding builder, which also implement this binding class. So you could put inside this binding builder. You can put your binding logic here, but for now we're going to talk about the Get.lazyPut, and we will talk about the binding later. So for the Get.lazyPut, it means you're going to load your instance when you need it, right? So you don't need to load it when we restart this application. As you see, this controller we're using Get.put will load into memory as soon as I press this restart button, right? So if we're using this Get.lazyPut, you won't see this in our console. Okay, so let's comment out this part, also this part, and here I'll create a button. Okay, I need to comment out this one as well. When I click this detail button, I will navigate to the detail page. As you see here, I'm using this net route. As you see here, I put this inside the get page. We're mapping this detail route to our detail page. So let's check about the detail page. So inside the detail page, we're using this controller. We're using this Get.find. So as you see, we didn't use Get.put here because we lazy put the controller in our view. As you see here, we're using this lazy put. We put this controller. So as long as we need this controller, you will load into the memory. And we can find the controller using this Get.find. And we have this count of variable, right? You see here inside this objects. And also we have this floating action button. When I press the button, the counter will be increased. So let's clear our console and we're going to restart our application. So as you see, for this dependence example, we only have the get material app. We don't put any controller in this page. So you will see on the console we only have this get material app controller has been created and also initialized, because we're using this LazyPut. So you will only load it when we need it. For example, I click this button. So in our detail page, we're going to need this count variable. During that time, this controller will load into the memory. So let's check it out. When I click this button, you'll see first we go to the raw detail, which you see is this detail page, and then you will see we have this controller has been created and also has been initialized. So that means we need this controller in our second page. Then you will load into the memory. As you see here, this one lazy load will create the instance we need it. And we also have some attribute associated, which is a dependence, means which class. It could be any class. And also we have this tag as the same as this Get.put, and we can create the unique instance. So by default, it's also create a singleton. So you will get the same controller every time. So what's more, we have this Phoenix, which means you will create from the same location if you set to true. So let's back to Visual Studio Code, and you see this console. When I click this go back button, the controller actually will remove from the memory. So let's see, when I click the go back button, you will see we close this row, and also the controller on delete being called, and also controller delete from the memory. If I set this Phoenix to true, we will keep our controller in the memory. So let's try it. We go to our view.dar, and in here we have this LazyPut, and we can set this Phoenix to true, right? And I'm going to save it. Okay, and we're going to restart our application. So keep in mind, if we didn't set this Phoenix, our controller will delete from memory. So let's try it, and we start this application. Okay, now the get material controller has been created and also initialized. So let's click this detail page button. So as you see, we need this counter, so the controller being created and also initialized. And I click this go back button. Our row closed, and also the controller on delete code. But this time we didn't see this controller being deleted from the memory, because we're using this Phoenix, right? We set to true. So next time we go to this detail page, you'll create very fast from the same location, because we save it in the memory. We didn't delete it from the memory, so it's very fast. We can create it again, and actually it works, right? See? So that's the Get.lazyPut. And next we're going to talk about this Get.put asynchronized. So let's back to our Visual Studio Code, and let's comment now this Get.lazyPut, and we have this Get.put asynchronized. So for here, we're going to create another class. As you see, we have some asynchronous task processing in the background. So in the front, we're going to await these 3 seconds. So I'm going to save this one, and let's see. So let's restart our application, and you will see when I click this detail page. Oh, sorry, I forget this controller. So we need to put this controller. So let's save again and restart our application. So as you see, we have this material controller, and watch this console carefully. So first, when I click this button, you will see this controller being created and initialized as soon as I click this button. And after 3 seconds, then you will see this asynchronous task class being initiated and created. So let's see. When I press this button, the controller roll into the memory, right? And you see after 3 seconds, you'll see the instance of this asynchronous task has been created, because it's a normal class, you see. So we don't have this on initialized method or on ready method being called. It's just a normal class. So you could put your fetching API here in this put asynchronized method. So the difference is it received the builder. So the builder is you can use a synchronized function. You can do some API call in here. Also, you have this tag, which is the same as those Get.put and LazyPut. And also, we have this permanent. By default, it's set to false. If you want this instance alive during this entire application, you can manually set this permanent to true. Okay, so that's basically for those most common used 3 instantiation method in GetX. So there are other 2 instantiation method. For example, this Get.create and Get.delete. So what's the differences between this Get.create and this Get.put? So as I mentioned, the Get.put will create only one instance among the entire application if you didn't specify this tag. However, if you're using this Get.create, it will create no shared instance, which means every time you call this method, it will create a new instance for you, and also the permanent by default will set to true. So for example, so let's back to our Visual Studio Code, and we're going to comment out this one. Comment out this one, and comment out this Get.create. So we're going to comment out this LazyPut, because we already create this controller by using Get.create, right? So, and if you move your mouse, you see the default, the permanent will set to true. So let's save and restart our application. And you will see when I click this detail page and the controller log into memory, and we see this counter here. So we're going to create another one. And by do this, you will see we have instant controller log into the memory being created and initialized twice. Also, I'm going to do some change on this detail page. So first, I create another controller. As you see, I'm using this Get.find. If we're using Get.put and then we're using this Get.find, you will find the same controller, right? So for example, here, and we have those 2 objects working on different count variable, right? One is from controller and another is from controller 2. Okay, so and let's back to this view.dar. Watch this console very carefully, and you will see the controller being created twice. So let's click this button. You will see we have a controller, right? Controller on init being called, and also controller on init being called, and we have a controller already being called twice. You see here, and this instance of controller being initialized twice. So it means this Get.create actually create 2 separate controller for this page, right? So when I press this button, I think only the first number will increase, as I see. And that's these differences between the Get.create and Get.put. So don't worry, I will talk this Get.create when we talk about the Get widget. So it's better to use together with Get widget with this Get.create. So the Get.delete means you can manually delete the instance by using this Get.delete. And however, most of the time you don't need this, because by default the GetX have this smart management and you will automatically delete those unused controller for you. Okay, so next we're going to talk about how you can find the controller. So back to this Visual Studio Code, and you see in our detail page we have this first approach. We could use this get.find, and we put what type of the controller we're going to find. So this is the first approach, and the second approach is I'm going to comment out this. So the second approach is you declare it is a type, which is the controller type, and using the get.find. So they are basically the same stuff. So it depends on you prefer. So those two actually do the same thing. This is how you can find the controller. So you could using this get.find.controller in here, right? You increment this count variable, and also you can use just this controller because you already find it and you have this type, so you can access to this controller, right? And you put in here. Another way is something like get.find, right? You specify the controller. So it basically means the same thing. Okay. So after that, we're going to talk about how you can alternate the controller by using two methods. One is Get.replace. So another is this Get.lazyReplace. Maybe you hear about the polymorphism in other type of programming language. Basically, it means you can use your child class to substitute your parent class. For example, here. So we have this parent controller. We put this parent, and also we have this child, and we're using this .put, right? So we manually put two instances into our dependency management. So I'm going to find in our detail page, right? So in here, I'm going to comment it out. So we have this child, right? As you see, we put both parents and child into the memory. So in here, we're going to find this child, and also I'm going to print if this child is an instance of the child. So we're going to save it and clear the console, and we're going to restart this application. As you see, we have this line of statement, so we only create this parent instance. This one actually didn't call because we have this parent. So when I click this button, we navigate to the second page, and you will see this one actually is a false. We actually find a parent. So let's change the position of this. So we're going to save again. So this time it will be true because we only load this child into the memory, and you will see this child is true, right? We have this child instant, so it will be true. But in the reality, you don't want to remember the sequences, right? Which line of code you write first and later. So here comes the second approach. GetX Pro I as this replaced, right? And we can replace this instance with this one. So that's it, and we can restart our application. And you will see first we have this parent, right? Allowing a create, and we call this replace. So you will delete this one and put this again, right? So this time, and when I navigate to our second page, you will see it should be a child instead of a child. So let's see. You'll see this is child turn to true. So replace means you will remove this from a memory, this instance of parent from a memory, and inject this child into the memory. And the Get.lazyReplace means the same thing, but you just lazy create the instance when you need it. So next we're going to talk about the binding. So for the binding, you can have two approach to bind your controller with your view. So the first approach is you create your own class. For example, for our detail page, we have this detail binding, which implements this binding class, right? And then we're going to override this method, which is the dependence method. So in here, we lazy put our controller, okay, and back to our view page. So I'm going to comment out this one and this one as well. And here we have this get material app, we have this get page, and we could using this way, and we binding our detail binding with our page. So I'm going to comment out this. Okay, we bind our dependence with our view, right? And also I'm going to using this one, right? Okay, and we're going to save it. So for our detail page, I'm going to comment this and comment this, okay, and comment out this, also comment out this, okay, save. And we have this route table, and we map this detail to this detail page, and in detail page we have this details binding. So in detail binding, we bind our controller, and we're using this lazy.put. So you will only allow this controller into memory when we actually in the detail page. So let's restart our application and watch the console very careful. And as you see, our Get material controller has been created and initialized. And when I click this detail page, and you'll see our controller actually create and initialize, which means it load into the memory, and we could click this button and the count increase. So we could using this binding, which you need to override this method. This is our first approach. We create this class and implement the bindings. So let's check. This is our first approach, right? We're using this binding class and with this name route. So another one is we can be using this binding class with a normal route. So let's comment out this one. Get page. So we're going to comment out this entire get page attribute. So in here, by this on press, we're going to use the normal route. We're going to use Get.to. So in the name route, we're using Get.toName, and we to the detail route. In here, we only are using a Get.to, and we go to the detail page, and we have this binding attribute. So we bind our detail bindings. So let's save, and we're going to restart our application. Yeah, it's probably the same thing. So when I click this detail page and we initialize our controller, right? So we could click it. Yeah, it works. So there are two approaches. So you create this binding class, and you can use it with name route and also the normal route. Okay. And I'm going to comment out this one and open our first approach. So I need to uncomment this. GetX also provide this shortcut for us. So if you don't want to write this binding class, you think it's too much work, you can just using these binding builders. The binding builder actually implement this binding as well. So you could using this one, and you actually receive the builder. So here you could do the same stuff you lazy-put your controller, we're going to save our code and restart our application. And you'll see we have a material controller create and initialize. When I click this button, our controller will be created and initialized because we're using this lazy-put, right? And this is a shortcut, and you can also use it in your normal route, right? You just place in binding attribute. So let's two approach to using the binding. So first one, you can create a class, and another one is you using this bindings builder. And the last thing I want to mention is the GetX have these smart management attribute inside the Get Material app. So you see, I scroll up to this material app, and we have this smart management. Smart management actually have three types. So the first one is for. Means it will dispose classes they are not being used and will not set to be permanent. So you will automatically delete those controller, which is permanent set to false, and also it will automatically management those for you. Another one is this only builder. For only builder, they don't have permission to dispose the class using Get.put or Get.putAsync. So they don't have a permission to delete the dependence using those two methods. So the last one is keep the factory. This one, it means you will save your controller in the factory. Then you will recreate the dependence when you need it again. Something similar with this Phoenix. And that's all for today's lesson. It's quite a lot of stuff, and I highly recommend you go to practice and you can understand it more. And I will upload this Mindmap and the source code in my Patreon. So if you are interested in those, feel free to reach out to my Patreon. I really appreciate for those people who support me. I can't do those videos without your help. So don't forget to subscribe to my channel, sum up my content, and open the notifications so you won't miss out the latest Flutter tutorial. Okay, thank you guys. I will see you in next video.